Yeah, you can start.
Okay, let's start. So, thank you everyone for coming today. Good afternoon, Prof. Good afternoon, TA. Good afternoon, students. So, this is our final project in 5G Foundation. So, this is the autonomous network slicing management for 5G core and PNX Smart Factory. So, my name is Isak, and this is Dimas Dermawan, and my friend Zafran. So our project is about internet-based networking with agent API. So our scope is from UE to 5G core network. So later our output should monitor the latency and throughput. And sorry, this is the reference paper that we use. This is agent API Empower internet-based networking for 60. And this is the outline for today. So the first one is background, and after that we explain about the problem and our motivation and our contribution, and also our architecture, implementation, result, and conclusion. And also we show you our demo. So this is the background. So background first is the 5G non-public network. So I'm going to explain about the non-public network is. So non-public network is a private 5G network dedicated to organization premise built for deterministic, isolated and reliable connectivity inside the factory. So this is our use case for NPN in a factory. So in a smart factory, there are some slicing. The first one is URLC below 5 milliseconds. It's using for robotic arm, the example. And URLCC below than 10 milliseconds is for AGV fleet. And also MMTC for the IoT sensors and video streaming with EMB. And this is our background. So network slicing contains these three types right in the 5G. So the first one is URLCC, ultra reliable low latency. So the target is below than 10 milliseconds and available in 99%. EMBB enhanced mobile broadband. So the target is multi Gbps, and the target should it's not important about the time, so it's 20 and 50 milliseconds. And the last one is MMTC or massive machine time communication. So the target is high density. And this is the internet-based networking. So internet-based networking lets operators for the, let's say, Chunghwa Telkom or telecommunication company. So the operator can state what they want, not how to configure the network, but a closed loop system translate the intent into the slicing configuration and validate them continuously. So the first one, operator intent. This is the example. So the example is the operator type please configure a slicing for a robotic assembly line with the target is below 5 millisecond latency. And our agent, the intent translator, will decomposition and check the resource matching and also create a slice configuration later. And after that, it will monitor our result in a closed loop assurance. And this is the problem that we found. So today, internet-based system cannot autonomously translate unstructured natural language intent into valid 5G slice configuration. So the first problem is rule-based. IBM is critical. So the structure policy language imposes accessibility barriers for non-technical operators and fail on paraphrase. And the second one is end-to-end machine learning models lack interpretability. So the other research use deep learning approach to produce the black box decision, but there's some gap that we found. So we try to use LLM to solve this problem. And the third part is plain LLM hallucinate configuration. And the fourth one is no multi-step reasoning for the idea.
So why in 5G we have this kind of network slicing, and the 5G non-private network, especially in the smart factories, we have various kind of network requirement for the devices. First, we can say some devices need the 5 milliseconds latency, and certifies it 99.9% validity, and they have so many UEs in one cell, and then for it requires a 24-hour, 7 days continuous operations because factories usually never have a holiday. And next. So the technical contributions that we contributed in our final project. So we use the free 5GC version 4.2.2, which is, I think, it's the most recent. So we have the first agentic AI layer, which translates the operator intent into the JSON, which later the JSONs will be converted into the configs for the 5GC. Then we have the React loop in the most right section. We have the React loop that validates our intentions. This is the high-level system architecture. So with the factory operator at first, and the factory operator will just need to interact with our orchestrator agents. So they don't need to open the YAML file anymore. They don't need to like go to the UPF and publish everything themselves, but just need to from the orchestrator agent, and the orchestrator agent will do everything into the core networks. And we have the core specialist agents, which will apply all of the configurations produced by the orchestrator agents, so that the slicings will apply to the networks. So we have for this React loop, which we have a maximum 10 iterations, which will, for this 10 iteration, it will try to create the JSONs for the networks. And first one, it will parse the intent and turn it into the JSONs, and then it will create the subscribers and assign corresponding slice to these subscribers, and then the next iteration is to verify that the configuration is success by checking the latency and the throughput. So, four technical contributions that we done in this project. The first one is the PCF KOS, which we adjust the container of the PCF in the 5GC, and then we also adjust the network function live reload, because before, if we change the slicing configurations, we need to restart the containers. So, okay, we adjust the code and no need to restart the containers now. And for the third one is UPF dynamic DNN. Right now, also for new DNN, it's not going to load without the restart. So we adjust the UPF so it can introduce new DNN in real time. And we also integrated the MCP server, which was someone also had it someone also submitted in the GitHub before, and we use that for our AI agents.
So I want to mention also that even though the MCP server itself has already a baseline, but they don't have the tools for creating the slicing, especially for the UPF and SSF, and also for the PCF. So that's why we also modify the MCP server so that it can have the tools to do the live reload and create the slicing in the network functions. And for the results, the end-to-end testing on the 2 VM, we use 2 VM. First VM is on the free 5GC, and the other VM is for the RAN network, which we use VRANSIM. And the working side is that for all the slicing management, it's working correctly. The system can create dynamic slice management. The UPF can enforce the slicing configurations and also the DNN routes, but we have some limitation, which is on the mostly on the run side, because the run itself cannot, and the GNB itself cannot enforce the configuration coming from the core network, and that's why if we want to make it work, we need to change a lot of things in the UE run sim code, and I think we don't have. It's out of scope for us because we focus on the 5G core network, and also the partial problem is in the policy function, because it's for the slicing chaos enforcement is not taking all of the parameters, so only some of them. But it still work and can enforce. But the main thing, like I said, the Eurasian cannot enforce the assigned slicing configurations, and we test it using the iPerf tools, and we will show the demo later. So this is the results. For example, I want to plan a 5G network. This is still a high-level specific language, because it mentions the ULC and DB and MMPC. But in the demo later, I will show you that the prompt is doesn't quote unquote mention any of the 5G terms. So the agent or the core, the system, can create the configurations for each slice. For example, the active users, how many active users, the slicing type, and the IMF, the necessary can create the slicing and store it in the MongoDB database, because Free5GC is using MongoDB database. So that's why every time the core system is reloaded, it will automatically load the slicing configuration from the database. So it's not a fixed and static configuration from the configuration file, and it can be dynamically added or removed by the system. And the SMF also have the configurations. And lastly, in the URANSIM, it can connect the UE to the core network, and it is log that it is that the UE is using the right slicing configuration. So for the conclusion, the agentic AI can manage the 5G NPN slicing. It will orchestrate for field JSON and maps it to the AMF, SMF, UPF, and also the web console. So there is no more handwritten YAML configuration for the Free5GC. And for our contribution, we validated in the VM, in the live testbed, that the log can show the NF live reload, and the PCF also have the QoS override, and also the UPF, and we also have the MCP server, extend the MCP server. So, and last one is the key limitations, which is the URANSIM. Like I already explained before, the URANSIM cannot enforce the policy, so that's why when testing the limit for the slicing, for example, for the URLC slicing, the maximum bandwidth may be only 500 megabytes per second, but when we test it using Hyper, the UE can still reach more than 500 megabytes per second, like maybe 2 gigabytes per second. Okay, so we will try to show the demo video. Maybe you can pause and can you zoom it on the prompt. In the chat, The prompt is I want to plan a 5G network for a factory. I have three types of devices. First, 33 machinery. It must have low latency and reliable. And 33 CCTV, 4K video streaming, and 33 IoT sensors for massive communications. And I tell please create the configuration for me and create all the subscribers. And you can see the LLM will respond. I'll help create a complete 5G network configuration for the factory, and it will call the tool. It says calling tool in here, and it is NSSF/this, which is the first. The LLM will try to know the existing plan for the 5G networks. That's why the LLM wants to know whether there is a slicing configuration first before creating the plan and actually executing the configuration. And also you will try to see whether there is a subscriber in the system or whether there is a UE first. And you can see that there is no slice exist yet. And so like in the flow, before executing and planning, the LLM will try to check the current condition of the 5G network by checking the slicing and the subscribers. And then you can, and then it will create the plan because there is no slice and there is no subscribers. It will try to create 3 network slices based on my prompt, which is it can correctly translate for 3 types of slicing. First is URLC for machinery, EMBB for CCTV because it's 4K video streaming, and massive type communication for IoT sensors. And it's successfully differentiate the slice type 1, 2, and 3. And it will try to create the slices using the tool NSSF/create. It is the tool that we create in the MCP and the NSSF. And you can again. Okay. So back pause for a bit. So after the LLM create the slices, it will check again whether the slice is created and with the and whether the slice is using the correct configuration or not. So that's why after creating, it will try to respond with all 3 slices are created, and then after the slice is created, it will try to create the configuration for the UE because I mentioned I also need the UE configurations. So, and before creating the actual UE, the Free5GC have the official Free5GC have a profile for UE subscribers. It's like a template for the UE subscriber. So when you want to create a new UE subscriber and you want to use the same configuration, you can just create in the profile. And for efficiency, the LLM will try to create the profile instead of manually assigning the same configuration again and again. So it is just creating a new profile, profile for machinery, CCTV, and IoT, and then later just apply the profile to the subscribers. Next. Oh. No. Okay. No. Okay. So this is the summary. After everything is done, the LLM will try to give a summary of what its plan and what execution. So it's successfully created 99 subscribers for machinery, CCTV, and IoT. And it will try to explain the configuration details. For example, all device using the element ID is 20993. And then the authentication, and also for the for the configuration for the slicing. And the next. Oh, okay. So you can see that the subscribers are automatically created. And this is one of the examples. The data network name is machinery. And you can see the 5QI is using the 8 type of 8. And the uplink and downlink configuration it also being set by the profile. Next. And this is for the profile. It has 3 profile: machinery, CCTV, and IoT. And this is for the IoT, which have the much more lower downlink and uplink configuration. If we compare with the previous type machinery, because it's URLC, and next is this one. So it can create 3 types of profile. Okay, yeah, that's all. Maybe you can create the docs and the report. I apologize because we don't include the UPF logs in the presentation because we forgot to do so. But as you can see in this, can you X? DMF. Scroll. Okay, this one. So it has the endpoint of admin reload slices. This is for automatically reload the slicing. So without the operator, no need to restart the 5G system. And then scroll down. This is for the UE connectivity. The UE is set up for video session. Is successful. And you can see also the interface and IP is already created. And this is for the configuration, the profile, using the SD and SSD based on the core network. And this is in the database. So if you see, if you show the network slices, it will show the 3 types of slicing in the database for the machinery, for the CCTV, and in the bottom below it has the IoT. So the database store the slicing configuration. And last one is the log for scroll. Okay, this one. As you can see in the PCF, it has a QoS override, which is using the UL and also downlink for the slicing. The SSD2 is for the machinery, and as you can see, it using the iPerf 3 tools, it can reach 2 gigabytes, up to 2 gigabytes per second. Even though the configuration state only maximum is 500 megabytes, only 1000 megabytes. So yeah. that's the result from us. The configuration in the management for the slicing is working, but the Uran sim cannot enforce the slicing. That's why it can maximize the bandwidth and the profile. Okay, I think that's all for our presentation. Is there any question?
Thank you. Any question?
No, just a few suggestions. The first one is well, in my opinion, that's just my personal take. When you're designing the agnostic agents, it is my view that you should limit limit the power. What I mean is try to make the agent as deterministic as possible. And one way to do that is to give a plan, like a reasoning plan, or like a way for the agent to reason through the problems. So that way, when it's reasoning, you can see the steps that are taken. Have you implemented something similar in your project?
Yeah, by the workflow of the React loop reasoning, it's because LLM is very hard to make it deterministic. To make it deterministic is very hard, right? Because it's generation. So that's why we test we test it whether it works or not by seeing whether the step of calling the tools is correct or not. So we enforce in the LLM that it needs to strictly follow our rules. And our rules is when you want to plan something, you need to first check the current conditions, and then create the slicing, and then create the configurations, and then check again the slicing.
Okay, so when you have such a plan, you should clearly state it in your presentation, like as a flowchart, right? Because that part wasn't clear. I did see some text, but the text is very small, so I couldn't read it. I just had to infer what was written, right?
I think we need to spend more time to create the presentation.
Okay, the second thing is I will give you props, as they say, for including what you were able to achieve and what remains to be done, or what you have partially achieved. But I would recommend in the future to more clearly state why it didn't work, or like to show the exact areas in the system graphically that have a problem. Because if you show a graphical indication of what works and what doesn't work via indicating maybe the network functions and the possible paths, you will not need to spend a lot of time to explain it. You could just point to the image and say, this is the path or the flow of the data. This is what we want. We have the network function. This is how the path. This is what we have. And then you can show, okay, there's a blockage here. And maybe you could indicate, okay, there's blockage and possible reason. So the more you are able to show on the screen, the less you need to speak. And as they say, image is worth 1,000 words, right? So if you have something on the screen, whoever's watching the screen can come to their own conclusions, right? And what you could also do when you're presenting is to, when you have an image, you can maybe pause and ask a question or two, or maybe you can ask if it's clear or not, and you can get some feedback to, you could modulate your presentation. So for example, if you realize everyone is sort of bored, you can say, okay, maybe it could be that I'm